All right, so today we're doing that big review for the quarterfinal, the third quarterfinal. And this quarterfinal covers so much stuff that I couldn't possibly record a video that covered all of it because it would be 90 minutes long, and that's just impossible to do in a 56-minute class period. So I'm going to start with number 12 here because this is the second of my 3 videos that I'm recording today. If you want to see the other parts, people listening at home, you got to go watch on the same website where you found this one. There's the part that covers the first 2 topics. This video is going to cover the middle 2 topics, and then the last video I do will cover the last 2 topics. All right, so starting on number 12. See how it says describe the graph's end behavior? That's just talking about up and down. You see how both ends, the left and the right end, are both up? So you just say up and up. And if you say left, up, and right, up, that's a good way to do it. Otherwise, if you only gave me 2 responses, the one that you have on the left, I will assume is the one you mean is the left side. So if you said up and up, obviously it's interchangeable, but I would assume that's the left side and that's the right side. All right, is the leading coefficient positive or negative? You remember how these things start with an equation like this? Blah, 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 and then they end with a number like 7 or whatever. Some stuff that we know about these equations. This number in front is the lead coefficient. As long as this is the biggest degree right here, then this number right here is the lead coefficient. And if it's positive or negative, tells me something. Do you remember what it tells me? Does it tell me the right end or the left end? The right end. It tells me whether the right end is going up or down. And since this one I wrote here has a negative, its graph would have to end going down like this. Well, this one that you have for real and have to answer is going up on the right. What do you know about the lead coefficient? Must be positive. And then say because. Basically, anytime you have a negative in the front, the right side has to go down. So anytime you have a positive, the right end goes up. One more thing about an equation like this. That stuff in the middle really doesn't matter. Remember that? Let's say I had this one. What does that plus 8 mean at the end? That's the y-intercept. Okay, can you tell what the y-intercept on your graph is? 0. So you'd have to know that the last number would have to be a 0, or in other words, the last term you'd have would actually have an x on it like this, because it doesn't have one of those. Okay, it doesn't have a constant at the end, so you could say it has a plus 0 at the end, or anyway. Then the last thing I wanted to talk about here was, remember the odd and even thing here? If it's odd, what do you know about the ends? They're going opposite directions. What if it's even? Then they're going the same direction. They're either both up or both down. So if you're taking notes to help remember this for the long haul, that would be one of the big ones. What the lead coefficient tells you is the right end. And if it's negative, it's going down. If it's positive, it's going up. What that tells you is whether both ends are going opposite directions, if it's odd, or if that number right here is even, then it's going in the same direction, either both up or both down. All right, write an equation for the graph. Well, for this graph, I would want to have y equals to start with. Remember, anytime you write an equation, you have to have y equals. Then I need to have some parentheses, and I would need a parenthesis for every single root. Like there, 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 and there. Holy smokes, 1, 2, 3, 4, 5, 6. I need 6 sets of parentheses here to write this equation. That is a little overkill. There probably wouldn't be anything that hard, but I'll make 6 sets of parentheses. 3, 4, 5, 6. Okay. Now, this one is at negative 15. Do I put x minus 15? No, x plus 15, because a negative 15 has to go in and solve it. And then do you remember the whole cut through versus bounce versus snake? This one is a cut through, which means it's only worth 1. That's called the multiplicity. The multiplicity is 1. When it's bouncing like this, that means it has a multiplicity of 2. So then this one is x plus 10 with a little squared on it. When it is cutting through like that again, it's a cut through. Although that's really hard to tell whether that might be a triple root right there. So do you remember how the snakes look? snake through looks like that, and that would be a triple root. Okay. This one, it's hard to tell. So in fact, that's another reason why we wouldn't have one like that on our test, because you'd have to be more careful about drawing a triple. Triples go from, they're always increasing the whole time or always decreasing the whole time. And they change from increasing at a decreasing to increasing at an increasing. Their inflection point has to be right where the root is. That's how you can tell if you have a triple root. All right, so that one I don't think is. I think that's just a cut through at -5, so I'm going to x plus 5. Cut through would be worth 1. Next is a bounce at 10, so that's x minus 10, because a positive 10 needs to be able to make it 0. And it's a bounce there, so I'm going to say squared. And the next one is a, did I miss one? Yeah, I missed the 5. Doesn't matter what order you put them in, so, no wait, there's no, 0, thank you. I can put x minus 0, but do you agree that x minus 0 and x are the exact same thing? So probably smarter to just put an x in there. Oh, I just lost my whole equation. Can I undo that? Let me see if it has that option up here. Nope, no undo option. I hope you were taking notes along the way. And I was trying to do this part right there, and that was giving me an empty thing with an x on it. And it's a cut through, so I could put a 1. And then the last one I hadn't done was another cut through, and that'd be x minus 15. And then it's a cut through, so it's degree 1. Remember those? Single cut throughs, double bounces, the triples of the snake one. Okay. Next, state whether each root is a single, double, or triple. Well, we just talked that through, so I hope you can handle number 15. It's just asking you about all 6 of those roots and whether they were singles, doubles, or triples. And that's based on whether they're bounces for doubles, cut throughs for singles, etc. All right, that pretty much covers up through 15. Number 16, increasing and decreasing. I hope you get that things like this red stuff, those are all decreasing. And how do you write the interval? Remember, it's all about the x numbers. X numbers of it tell you where it's decreasing. So like in this little zone right here that I'm going to make green, in that little zone there, it's from here to here, the x numbers. So from negative 3.34 to negative 0.66. And these, I usually just have parentheses on both ends, but I'd accept brackets on both ends, because that would end up being an argument about, is it actually decreasing at the top or at the bottom? I personally don't think it is, so it's parentheses, but we do allow brackets on that kind of problem. Go ahead. Okay. Here's another one where it's decreasing right here, and that would be from, well, this is the x number, but what x does it start with? Way over there would be negative infinity. So this one right here would be described by saying negative infinity until -5 is where it stops decreasing. Parenthesis, parenthesis. Probably safest to use parentheses, because if you ever put a bracket on an infinity, it'd be wrong. So, because you can never get to infinity. So parentheses are probably the safer choice. So there's 2 of my 3 decreasing ones. This one's decreasing too. Always remember it's the x's of it. So it's from 1 to, and how it's way over there in the x world, 1 to positive infinity. A lot of people say, but it's going to negative infinity. That's the y. We're talking about x. The x of it is the first number. So it goes from 1 to infinity. So there's all 3 decreasing intervals. Hopefully you can handle the increasing ones yourself. Next is extreme values, minimums, maximums. Those are really simple. They're the high spots and low spots in the graph. So here is a maximum. That's a local maximum. Here's another local maximum. And then there's minimums. That's a local minimum, a low spot. That's another local minimum, low spot. And then there is no absolute max, because see how the graph is going up here, and it's going to keep going up, meaning there's no maximum for it. And this one keeps going down forever, so there's no absolute minimum. So in both of these, it would be none. Is there ever? Yes, there is. If I had a graph that was like this, and it goes up on both ends, then it has no maximum, but it does have a minimum. That spot there is the lowest it ever goes. So its minimum would be at that spot. That's its absolute minimum. This would be not the absolute minimum because this other spot's a little lower, see? So this spot's the absolute min, and this spot's just a local min. And that one technicality, I don't think it'll come up, but can it be the local min and the absolute min? Yes, it can. Just like if one of you kids in here was the strongest 15-year-old in the world, wouldn't you be also the strongest 15-year-old locally? So you're a local maximum and an absolute maximum then. So it can be both. Okay. And judging by the flexed biceps I saw, none of you probably are. All right. Clearing. Apparently, in my kids' school, there's this guy, I don't know if he's a freshman this year. I think he's a freshman this year, who is pretty amazing strength-wise. So, like, his thing is bench pressing people. So he will take a person and they like wrap them up in a piece of carpet or something, so they're easier to handle, and then he'll like bench press them just over and over and over and over. So they have this competition where it's like a pep fest thing where this freshmen versus sophomores versus juniors versus seniors, and he's quite the animal as a freshman. So, all right. Anyway, let's talk about some of these factoring problems. Do you remember the factoring test? Wasn't that fun? Many of you did all right on it, but some of you had some trouble on the last 4 or 5 of them that were the really hard ones. Do you remember what tool you were allowed to use that made it easier? The calculator. Everybody grab your graphing calculator. There's going to be a part of this test where you can use graphing calcs. This would be one of those moments. I'm going to pause for a second while you get those. Now you may still be in that weird calculator mode that's like for sequences. If you are, go to mode and then get down into funk mode. And yes, I just said get down into funk mode. I'll put on appropriate music for that later. All right. Function. So once you're in function mode, how do we do these again? Well, let's look at number 22. You know what? I don't need a calculator to tell me how to start this one. Remember, the calculator is only really useful to tell you what would be a root. But I can see a root right away. What goes into all of those? A 2 and an x. At first, I was only noticing the x, but you make a good point. There's a 2 in all of them also. So I'm going to factor out 2x and then see what I have left. X to the 4th plus 5x squared plus 4. Do you agree? Okay, now, do I need the calculator to do this next part? Nope. If I wanted to, I would graph this and see what root could possibly be a factor, and then I could do synthetic. But a lot of you made this mistake. You thought you had to do every problem with the calculator. No, this one doesn't really need the calc yet. Do you know how to do this with factoring? Just plain old-fashioned factoring? 2 sets of parentheses. How do I start both of them? X squared and x squared. And then you do the old-fashioned, this number is these 2 things multiplied make 4. And they have to multiply to 4, and they have to what? Add up to 5. What 2 numbers multiply to 4 and add up to 5? A 4 and a 1. And then, should they both be pluses or both minuses? Pluses, because this middle term is positive. So the outside now and the inside, do they make a total of 5x squared? Yes, they do. And that's the one you really got to watch out for, is the middle 2, the outside and the inside. Now, don't forget my 2x here. There, I brought it down. That's a really common mistake, is to forget that you factored out a 2x at the beginning. Now I got to check for my roots. It says find all real and imaginary roots. And by the way, this one is factored completely. Don't try to factor things that have a plus in them like this, but if that had been x squared minus 1 and x squared minus 4, then they would have factored further. Do you remember that? X squared minus 1 factors into x plus 1, x minus 1. Remember that pattern? in case you forgot it, I'll do another one like that. If it was x squared minus 4, it'd be x plus 2 and x minus 2. You take the square root of this number. Okay, that's called difference of squares. That could definitely come up. All right, so back to the one we were doing. I've got it factored all the way. Now I got to find the real roots. That's a root, because if you set it equal to 0, putting in a 0 right there would make a root. If that had just been a 2 and there wasn't an x there, that's not a root then. The reason it's not a root then is because I can't make a 2 into a 0, can I? But if there's a 2x here, like there really is, I can make the x into a 0, so x equals 0 is one of my roots. This is not a real root. I can tell because I can't make this part equal -4, can I, unless I use imaginary numbers. Okay, so this one's a real, and this would be imaginary, and this would also be imaginary. And if you're not sure whether they're imaginaries or not, just find them, and if they have a negative under the square root, they're imaginary. Set that equal to 0, set that equation equal to 0. This one's a little cleaner, so I'll start with that one. I'd say x squared, and I'm subtracting 1 from both sides, is equal to -1, square root of that, square root of that. This is technically the absolute value of x, so that reminds you, oh, by the way, square root of -1 is I. And then, remember the absolute value thing reminds you there's two answers, plus and minus I. That's one of your imaginary roots. And then this one right here, I'm going to make that one a little bigger here. X plus 4, x squared plus 4 has to equal 0. X squared has to equal -4. Square root, absolute value of x. Don't forget that, because it's not just x. Equals square root, if that's 2, but then there was a negative in there, 2i. Final answer, plain x would be plus and minus 2i. Because to get this square root off of here, I have to make one of them positive and one of them negative. Positive 2i, negative 2i. Okay, so there's 2 imaginaries, 2 more imaginaries, makes a total of 4 imaginaries and 1 real. That adds up to 5, which is what I wanted, because the biggest degree was 5. That's a really smart thing to check at the end, is if it's got it to the 5th power, you better have 5 roots. Otherwise, you did something wrong. But don't forget that these kind count for 2. That's plus I and minus I. And this is plus 2i and minus 2i. So those are 2 each. Makes a total of 4 imaginaries. Okay, so that one did never even need the calculator on that one. I'm going to clear my ink here. And then, ooh, my ink sounds like I went and got tats. Number 23, I'm going to factor this one. I actually do need the calculator, because it's got 5 parts. I can't possibly do factoring by grouping on that puppy. So I'd probably need to factor or put that in the calculator. I'm going to pause for a second while I type that in my calculator. All right, I'm back with you. So putting that in the calculator. Why? Because I want to find out what could possibly work. I don't want to have to do the rational root theorem and say that all the factors of the constant over the factors of the coefficient. Remember that? That was a pain in the neck. Got so many things to check. So I'm going to just use the calc. Clear that out. I'm going to clear that out. Go up to here and put in x to the 4th. X to the 4th. Arrow to get out of that. Minus 4x to the 3rd. Arrow to get out of the exponent there. Minus x squared minus 16x minus 20. Yay, finally done. Now I hit graph, and I hope that it touches the x-axis a couple times. I don't like how this is graphing. I'm going to hit on to break it, otherwise it keeps running forever, because my window is goofy. I'm going to go to zoom 6 and hope that that window will be better. Now I'm going to try graphing it. Okay, looks like it touches twice. Looks like -1 and 1, 2, 3, 4, 5 maybe. All right, so -1 and 5. Don't forget, both of them are important. -1 is probably a root, and 5 is probably a root. That means I'm going to do synthetic twice. I'm going to do it once with the -1, and when I'm done with that, what's left over, I'll do the synthetic again with the 5. All right, so here's my -1. Do I have any placeholders to worry about? It goes 4, 3, 2, 1, and yeah, that's all good. So if that had skipped any terms, you know what? Remember I have to have placeholders? Okay, now I'm going to go 1, -4, -1, -16, -20. Draw the line. We know this is going to work because of the calculator. It's kind of cool. 1 drops down, -1. That was a multiply this to this. Now I'm adding these, -5, multiplying those, +5, adding those, +4, multiplying those, -4, adding those, -20, multiplying those, +20. It worked. Yay. Now here's where a lot of kids screw up. The answer for this part is x plus 1. But this next part here is really a crucial part. This is the x to the thirds, this is the x to the seconds, this is the plain x, and this is the constant. And you do not need to regraph this thing. Why don't I need to regraph this to find out what goes into it? Because I already graphed it, and I know 5 is going to go into it. See, I just did the -1, and I knew that worked. 5 will go into it. But there's an even smarter way than synthetic. Who sees it? You see it? Factor by grouping. How did I know factor by grouping would work? Because the ratio here is 1 to 5. This one's 5 times bigger than that one. Do you get how that one's 5 times bigger than that one? Anytime that happens, factor by grouping will work. And I like factor by grouping better personally. Now, if you really like synthetic better, you should go off to the side of your paper and do this. 5, 1, -5, 4, -20, and do it that way. That would it's totally fine. But I'm going to factor by grouping just to remind you how that goes. So what goes into these two? X squared. What's left when I'm done? X minus 5. What goes into those two? -4 is even better. X, oh wait, no, +4 would have been better. Because if I do -4, I got to do, no wait, yeah, I got to do this. And see how these aren't going to match then? So I better not use -4. I better use +4. I'll take a +4 out, and I have x minus 5. Those and those are the same. Final answer, x minus 5, x squared plus 4 is what I have left. And then don't forget to bring these down. X plus 1. That's how you work out that kind. Now, do I have some real roots? Yup. -1 and 5. That's going to be imaginary because as soon as you set it equal to 0, you'll end up with x squared equals -4. You have to do square root of a negative. Hopefully you can handle that from the practice one I showed you before. All right, so I worked you through some hard factoring problems. If you did those with me, then you remember it hopefully for tomorrow. All right, and I've covered, see, which sections did I cover now? I covered starting at number what? 11, I think. I covered higher degree polynomials, and I covered factoring higher degree functions or polynomials. The next section here is what I'll start with next hour, and if you want to see how to do those problems, you should go watch the video that covers rational functions. It'll be posted tonight. I'll do it next hour. You get how this is working? So you got 1/3 of the packet done with you, and the other 2/3, if you need help, watch the videos. All right? Okay, that's all I have for the video for today.